RAB, resistance between A and B. A circuit cannot be given like that and asked to find out the equivalent resistance without mentioning 2 points. Nobody can simply say find out the equivalent resistance of a circuit. It is actually resistance between any 2 points. I told you already, you'll think that a cell is connected across these 2 points. So the whole circuit will send a current through the cell. Actually, cells sends the current through the circuit, but all that will flow through the cell. So if I remove all this combination of resistors and put one equivalent resistance, whether that will draw the same current from the cell is the idea for equivalent resistance. All right. So look at this circuit here. See, this kind of a thing, when it comes something from behind like this, it means there's no connection there. So the circuit simply becomes one like this. I hope you followed this. All this point is at the same potential, say plus V. This will be at 0. Isn't it so?
Yes, sir.
So you can think of sliding this side like this, move it up, slide it down, slide it down. There's no connection between the two. That's what we showed here. R, 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 R here. Right. So what shall I do? R and R will give you 2R. This R and this R will give you 2R. All are in parallel now. Isn't it so? All this is at V, this is at 0. This will be 2R, this will be 2R. 2R and 2R in parallel once again R. R and R parallel R by 3. So for this kind of questions, you should not write too many diagrams and all that. Do you understand this? But in this case, slightly different. There's a connection here. Once you cross like this 2 wires, it means there's a connection, but not a big deal. Even that will be like this. Just a minute. That is. So you can simply put it like this. R here, R there, and R here. Isn't it so? And these two are in what?
Parallel.
Again. Which two? These two. These two are in parallel again. Jin Kumar is going on, coming and getting out. Okay. These two are in parallel. R parallel is R by 2. Isn't it so? By this time, you should write it straight away. Don't write 1 by R, 1 by R, plus 1 by R, all that. Okay. So R by 2 here, R by 2 here. Huh? What do you say? These two are in series. So R by 2, R by 2, R. That this R, this total R, and this R are in parallel. So finally, how much is that? Huh?
R by 3.
R by 3 again. So small difference between the two, you need to understand. This problem is given to tell you that when you put that diversion, this one, like this, that is no connection. But you just cross 2 wires, there's a connection. But don't forget, once again, the whole idea is based on this being an equipotential path. This is another equipotential path. So because of that, the whole circuit, all the resistors are in parallel between these 2 points, A and B. Okay, children? Anybody did not follow? Ask me quick. Actually, without writing the equivalent circuits and many figures like that, if you are able to calculate in the mind this kind of things, it actually tests your actual understanding. You cannot go on writing steps for simple questions like this. You should not, actually speak, because you know already that I should look at potentials and currents. All right. So I think I can move ahead. All right. This one. Between A and B, find out the equivalent resistance. Look, what will happen if I connect the cell like this here. If I connect the cell here, you can think that current is entering from A. So it will divide like this here. What do you say, children? Once again, it will divide into these two. This will divide once again into these two. It doesn't divide here. This current will join here and come here. This current and this current will come here. And finally, we go to the B. Every time that should be our overall thinking. Current will come out of plus, divides into many branches, but finally enters the minus. I've told you in the beginning itself, when we started, we are thinking of a single cell and many resistances. So that is the idea. There are so many ideas in this lesson, so many, as far as circuit analysis is concerned. Okay. Now, we need to start reducing the circuit from the remote end from the battery. You understand the meaning of remote end? This is my remote end. Remote from the battery, away from the battery, on the other side of the battery, let me say. So go on pushing the circuit to the points, between the points A and B. So 3 in
Series.
will be how much?
9.
9 and 9 in parallel. That is 9 into 9.
9 by 2.
9 by 2. 4.5.
5.
Now 4.5, 1.5 and
1.5, 6.
Are in parallel.
how much?
Series.
4.5 plus 6
12.
12, sir.
1.5. So how much?
12.
12. That 12 and this 12 are once again in parallel.
Parallel. 6.
12 by 2, 6.
6. This 6 and this 2 and this 2 are in series.
10.
10.
10 and 15.
Plus 2 plus
16.
10. 10 and 15 are in parallel again.
Parallel. Yes, sir.
10 into 15 by 6. Is that right? So that's how
Yes, sir.
the circuit will be simplified. So there's nothing big about it. But remember, as I told you, the small idea, the main ideas of the lesson or a particular concept will be focused in a simple question. When I said that, other requirements of problem solving will cloud the main basic there when you are doing a bigger question. But here, yes, I connected a cell. First of all, anytime, whenever you wanted to find out the equivalent resistance between 2 points, you think of a cell between those 2 points. So that's the minimum thing you need to do in the beginning. Then think of dividing currents or dividing potentials. Is it all right for you people? Tell me.
Yes, sir.
Okay. I'll go to the next question. This time I go to the next question. Isn't it so? This one. This is called infinite ladder network. Really? This kind of wording you see. Infinite ladder network is a name given by electrical engineers. Infinite ladder network. What's happening? This on the right hand side circuit is going to infinity. So from the problem we've done previously, we know that we need to start at this side to keep reducing the circuit to the points A and B. But where do we start? You know, the first thing in this kind of a circuit, there will be many like this in future. You need to decide the basic unit of the circuit which is getting repeated. This is the one which is getting repeated. You can call it a unit cell if you want. The minimum most configuration there is that. So this is going on repeating. Isn't it so? This is first cell. The next is cell means unit. This is the second one. I'll just put it to the different color to differentiate between the units. This is the next one, isn't it? And then another one. This is the another one. So 1, 2, 3, like that is going up to infinity. Tell me. So you add something to infinity, it remains infinity. You remove something from infinity, it remains infinity. What do you say? Infinity is not defined. So adding something and removing something doesn't really make any difference for the situation. I remember one of my teachers telling me, infinity is like ocean. Take some bucket of water from that, it will remain as ocean only. Add one more bucket, it remains as bucket. We said, wow. All right. Now, what shall we do? Between these 2 points A and B, I require the resistance, which means we think of connecting a cell like this and think of dividing the currents like this. So in the previous circuit, you've seen we'll start somewhere here, make it 1 and then go until the battery. But what shall we do for this? Look, if I redraw the circuit again here, can put many. For example, if I just look at the circuit here, we think of separating this element out, the remaining thing looks like what you have there already. Do you follow that point?
Yes, sir.
This is AB. But if I cut it, these points will look like AB. Isn't it so? For that matter,
Yes,
if I cut
sir.
it here also, it doesn't make a difference. I mean, after one more cell. Do you follow the idea here? This is a crucial thing here. Probably this is a question for your mathematical induction. What is mathematical induction? Can people tell me quickly? Please, I can.
Sir,
Hmm.
we use mathematical induction to prove some statement.
Tell me, how do you do that?
We'll think that the statement is true for some k,
And then prove it true for?
k plus 1.
But let's not do it so big actually. We'll do it in a simple way, but the direction is towards that. Now, did you follow this? If I think of this one, if I cut it here, the remaining circuit looks like the original circuit. Is it okay?
Yes, sir.
Then
Yes,
what
sir.
I do is, I'll think the whole resistance of this circuit is X between A and B. Let me say RAB equals X. Now, resistance of all this is also X, right? If I remove it also, it will looking like same. Do you follow this?
Yes, sir.
Yes, sir.
Therefore, I'll do like this. This is R, this is R, whole thing is X between A and B. Tell me, children. Now, this circuit will be rewritten as R. These two are in parallel. Rx by R plus X between A and B. But resistance of this should be once again equivalent to what? X only.
Yes, sir.
I've written X here, isn't it? So R plus Rx by R plus X is equal to X. This is the idea. The rest is calculation and solving a quadratic equation. We'll do that anyway, even that. So, but what did I mean by saying that mathematical induction or anything like that? I proved for 1. I can prove it for 2 if you want. I can prove it for k and I can show that is k plus 1. It's also correct for k plus 1. That's not important if you really, only if you want, you can check for 2 units added to the infinite x. So what will happen here? This will be r square plus xr plus xr is equal to xr plus x square. So when xr going away, what do I get? X square minus xr minus r square equals 0. So x equals minus b, that is r minus r, that is minus of minus r, plus r minus root b square r square minus 4ac. This is minus r square here. So plus 4r square by 2 into 1. So r plus r minus root 5r by 2. So minus will be ignored because minus is more there. There's no minus resistance here. So it's simply root 5 plus 1 r by 2 is x. Tell me, children. Actually, if you want to check it, you can. Somebody should actually immediately ask it out. I took only one out of it. Can I take two and do? Take two out of it and do. You'll still get the same. That means it is independent of the number of those basic units there. Tell me, children. Do you follow?
Yes, sir.
Yes, sir.
Taking two and doing it will be slightly linear, but you'll end up with the same equation, same value. If you want, you can check it. Enter, whatever you are asking, tell me. We'll try somewhere. I mean, I don't know whether I have a slide here for that, extra slide. I should go to design mode in that case. So somebody was saying something. What I was telling is, it's worthwhile to check. Even if I cut these two, still the whole thing will, because infinity is looking like the old one. So I can take this whole thing to be x, add this and make it equal to x. Tell me. Siddharth?
Sir,
Siddharth,
sir,
have you understood this?
yes, sir.
Okay. Gautami. Shreya. Akash, are you there? Bhavana, any question here?
No, sir.
One, when you cut one and remove that from there, the circuit looks like the same old circuit. Do you follow that?
Yes, sir.
So, of course, should go up to infinity here. So, is the calculation right? If you think you followed this, there is another one, similar one. So, if you attempt it and get it, that's enough. But somebody has the patience, you can take two cells separated and add it to the infinite x and make it equal to x again. Even then, you have to end up at this answer. Do you really follow? Like we stopped at one, you need not, you can try with two. So then we can try with any number of cells. Did you people understand this?
Yes, sir.
Huh?
Yes, sir.
So you can try actually and tell me whether you got it or not. Once again, a quadratic equation of the same quadratic equation comes. So it's time we go for the next question. We're still doing. Lakshmi. Okay, I'll go for the next question. The idea if you catch, the remaining is only algebra. Try to understand. I need not have to show the algebra, though I have shown it here. So, okay, another one will follow. For those who want it again, I will bring it back, but do this one. What is the difference now, children? Only down, this resistance has come. So the first thing is what? We need to look at that basic unit which is getting repeated. So which basic unit is getting repeated here? This one. This is the unit cell, if you want to say. This one. You make one like this, then duplicate it. That's how you get the infinite network. You understand what I told? You make one unit like this and duplicate it and join it to the end like that. It becomes an infinite ladder network. So people who have understood the previous one, start trying it immediately. You'll put this basic unit in parallel with the resultant X. I'm still not sure whether all of you followed it, but others who did not follow should open up and ask. Remember, just this idea can be converted into very, very good questions later. So,
Sir,
yes,
is it r into root 3 plus 1?
possibly. I don't remember the answers anyway. By 2 is not coming.
No, sir.
Okay, it may be that. So the next circuit will be what? R. This will be Rx by R plus X. This is R between A and B. So all of them are in series. So R plus R, 2R plus Rx by R plus X should be equal to X again. X is the equivalent resistance, the total resistance between A and B. So even after cutting one, since it is looking like the same old one, we are calling this also as X. That is the idea. Okay. Now this is all simplification. So 2
Sir, R times root 3 plus 1 వచ్చింది sir.
2Rx plus Rx is equal to Rx plus X square. So you get it, X square minus 2Rx minus 2R square equals 0. So minus B plus R minus root B square minus 4AC by 2A. If you do, what are you ending up with? X equals how much?
3 plus 1 into R.
So this is going to be the answer. Tell me, children. Anurima? Anurima, are you there? I don't know. Now, simple things like this. This, I expect you to do these things. If it's not clear, I'm showing it again. Come on. Connection here. RAB equals how much? Is the old one over with everybody? Khaja, are you there?
Yes, sir.
Avinash Reddy?
Yes, sir.
So is this 13th over or not for you people?
Over.
Now, 14th. If you have problem in doing it, you need to speak now, because I've done already enough number of questions to get you a feeling of series and parallel. And I already told under series and parallel we are doing in a miscellaneous set of examples. You won't be knowing whether you should go for series parallel connection or whether you should apply Kirchhoff laws or whether you should go for Wheaton's bridge. You won't be knowing. But this heading itself is series and parallel. So it's one hurdle is already crossed. What is it? We are saying that this is in, you have to do it from either series or parallel idea. So what shall we do? Can somebody speak? Look, this is plus V, this is 0 when I said. All this is an equipotential line, right? So
Yes, sir.
somebody connected it for no reason this way. So the circuit simply becomes a simple, very silly circuit like this. Isn't it so?
Yes, sir.
All this is same.
And
Whether you connect it here or here doesn't make a difference, right? And then one here, and then like this. Sorry, there's no wire in the middle.
There is no resistance.
That should not be there. If it is there, it becomes different. So this is one thing like this. What do you say? So this is 2, this is 2, this is 2, this is 2, this is 2. Between these 2 points, we want equivalent resistance. So these two are in parallel. This and this are in parallel or not? It's equivalent to connecting these two here only. This line is once again equipotential thing. So 2 and 2 in parallel will be giving how much? 1.
Two, sir. One.
These 2 and these 2 in parallel will give 1. These 1 and 1 are in series. Isn't it? So 2.
Yes, sir.
2 and 2 are in parallel again. So answer is RAB equals 1. You have to come to recognize the points of same potential. That is going to be the main idea. And also, if you don't like it, if you don't want to do that way, it will keep bothering you all the time. That's only trick or the challenge you've got in this kind of problems? So somewhere you should say, no, sir, we understood it, stop it. Otherwise, you can create, you have to create many more problems and there's no end. No one can say that I exhausted the possibilities and series and parallel. Scary looking and complicated looking sums will yield to the series and parallel many times. If they are not yielding to that, then we have other methods. So I'm taking one idea at a time. So tell me, Chinmay, did you follow this 14th one? Not sure. You need to respond, children, because I won't be knowing. Like the main ideas are you catching is the main thing, no? So 15th one, somebody speak. If you really understood it, tell me what to do. Yes, Dishita, can you try the 15th one?
Yes, sir.
Tell me, how should I approach the question? Start from the cell anytime. Say this is some V, this is some 0.
0. Yes, sir.
That means all this is 0 potential, right?
Yes, sir.
As this one. So between these two, if somehow this becomes 1, that will be in parallel with this, right?
Yes, sir.
And remember, this is all V. So this 2 is equivalent to be here. That you need to really understand on your own. If I tell any number of times, that may not work. This 2 is also at plus V, this is all plus 2. So this 2 will go and join here. Can you see that? This
Yes, sir.
is
Yes,
like
sir.
here only. This 2 and 6 in that case are
Parallel.
Parallel.
so 6 and 2 in parallel will be how much? 6 into 2 by 6 plus 2. 12 by
3
8.
by 2, sir.
6 into 2, 12 by 8. How much is that?
3 by
3 by 2.
3 by 2. That is 1 point.
1.5.
Is 1.5 and 1.5 are they in series?
series. Yes,
Yes,
sir.
sir.
Huh? So 3. This 3 and this 3 are in parallel.
Yes, sir.
So 3 and 3 parallel means how much?
1.5.
So the total resistance between the plus and minus is how much? 1.5. So current is 6 by 3 by 2. 4 amperes.
4.
So should never think that this circuit has to be rewritten in many shapes. That will be such a waste of time, actually speaking. No, actually, if you do that, if I do that, for example, go on writing many more circuits, you'll actually become lazy. Your mind becomes lazy. You always look for somebody else to show you that total solution. For that too, for a silly question like this. You look at the circuit, don't put the pen immediately, think for a while, and in case it is looking a little more complex, you can put the pen. But otherwise, this kind of a question, people should be able to do without using the pen. Then you understood the meaning of series and parallel, I can say. If someone did not follow, tell me quickly. We'll move on.
Sir, why 2 and 6 are in parallel?
Why?
2 and 6 are in parallel.
Tell me. You mean they are in series? Huh?
I can't.
Look, this is all plus V. This is also plus V. So end of this 2 is at plus V. End of 6 is also at plus V, and there will be some other potential here. Call it V1. So V minus V1, V minus V1, potential difference are same for this and this. In other words, I'm telling you this 2 is equivalent to be connected here. So if this is all equipotential, what is the purpose of having all this? You can simply connect it here. Then you say one is above the other, they are in parallel. Will you want to say? I actually don't want you to think like that all the time. I should put it above this way. I'm telling you, I want you to look at simply as it is there and see whether potential differences are same or not. Tell me, Varshit.
Yes.
Okay, then. No, otherwise, if you don't ask, I'll think that you're following because there's nothing like a new idea in this, right? Huh? But you need to make a little leap in your faith. What is that? There is something called meaning that I'll catch. Not try to make it look only logical. Look, logic doesn't always have meaning. Logic is just pure logic. That's mathematicians' work. So, Varshit asked anyway because somewhere you need to ask. Otherwise, however many number of problems you do, still you don't get a hold effect. Okay, I'll be continuing, children. We should be able to finish these things because next class I'll start the next heading. Come on. If somebody wants to try it, I'll give you the opportunity. I think some PDF conversion I did unnecessarily, so it made the diagrams look a little bad, but okay. Now tell me, how should I go? And this kind of a bypassing is what? No connection between this wire and that wire. Find the current in the battery. Find the current in the battery. Where is the battery? Here, 12 volts. And no internal resistance is shown for the battery. So what should I do? Come on, children. Who will try it? Harshini, are you there?
Yes, sir.
Tell me, Amma, what shall we do?
6 and 4 are in parallel.
6 and 4 are in parallel, Harshini says.
Then
That's
8
correct. I'll put it here itself without drawing one more figure. I'll put for your benefit like that, the way it should look. And then, Amma?
8 and 2 are in parallel.
8 and 2 are in parallel. That's all. Okay. Huh?
Yes, sir.
And then after that?
That equivalent resistance again is parallel.
Equivalent is parallel or series?
Sorry, series.
6 into 4 by 6 plus 4 is this. How much is this?
2.4.
This is 8 into 2 by 8 plus 2. You see?
1.6.
These two are in series or parallel?
They are in series.
They are in series. So 2.4 plus 1.6 equals how much?
4.
4. This 4 and the other 4 are in?
Parallel.
Parallel.
So the current will be what?
6 amp.
That's it. So have you understood that this 2.4 and 1.6 are in series?
Yes, sir.
Sir, I
Yes.
don't understand.
Huh?
Yes.
For that, you need to draw one more figure if you want. Actually, I told you already, this kind of questions, I generally don't prefer you people drawing because I don't want your imagination to get spoiled. This is how much? This is 2.4. So this is how much? 1.6. So aren't they in series? Huh?
Yes, sir.
Look, from this circuit to that circuit, go from here to there, you'll understand it. And after that is done, but this is actually a very, I don't like this kind of a thing because every time without your knowledge, you are coming to a situation where you want to look one above the other, one after the other, which I really don't want for you to think. Why that kind of habit we should give to mind? Huh? You should be able to look at those things here only, not just trying to put them like this. That's where actually everything has got spoiled, in this kind of problems. For the sake of convenience and looking easy, people try to draw so many figures, and every time they try to bring things like this, one after the other series, and one above the other parallel, like that kind of a what you call habit for the mind is not a good idea. Without writing, without taking a paper, or before taking paper, you should pause and just look at it for a while. For every problem in physics, that's the idea. Try to understand. Not only this. So this immediately you start writing and without deciding as to what to do, and without deciding as to how I can make it smarter, because time is an issue in the exams, right? So you just for a while need to think as to what's happening. I hope this is over now. I'll continue with the next one. Come on. Just read the question carefully. This is a rheostat, a variable resistance here. This is an ammeter whose resistance is 0. That is ideal ammeter I told you previously. That should not affect the current we are going to measure there. Because if you put that R in series like that, that will change the whole current. So for that reason, we said it is 0 for a while. This is 10. This is 20. This is a rheostat. You can move the slider from here to here, depending on how much resistance you want to be included in the circuit. I maximum, I minimum through ammeter is what? This is I maximum, and I minimum through ammeter is what? 1, 2. I maximum, I minimum. That you need to find out. Not a serious one. For the look, this rheostat comes here and connects. So what will happen? Resistance will increase in the circuit or decrease?
Increase.
It will increase. If the current is increasing, and there's a maximum resistance available there. If I go to the edge of it, in the labs you will see these rheostats. They will be like this. A cylindrical tube will be there. Over it, wire will be there, and a slider contact will be there, which will be moved across it, so that the resistance you want will come into the circuit. So the slider contact will be here. Resistance will be highest. That's where the current is least. If the slider contact is here, this won't come into circuit. So resistance is minimum. Current is going to be maximum. So 10 and 20 in parallel will give how much? 20 into 10 by 20 plus 10. 200 by 30. So 5.5. So I max equals 5.5 divided by 20 by 3. Whatever it is. Okay. Now for I minimum, what should I do? I put the slider contact here. So in which case this 20 by 3 is series with 30. So 20 by 3 plus 30 is the equivalent resistance here. How much is this?
110 by 3.
110 by 3. Yeah? So now the current is I minimum is equal to what? 5.5 divided by 110 by 3. So you can find
0.15.
Huh?
0.15.
This one,
Yes, sir.
that one,
That one is
0.825.
8.
0.825.
so this is I maximum, this is I minimum. I hope you followed that rheostat business. 18th question, children. Himanshi, are you there? Himanshi,
Yes, sir.
now tell me how to do the 18th one. Now somewhere I should feel that now these ideas you've got. Otherwise, whatever number of sums we do, it doesn't work. Somewhere people should say, no sir, I've got the idea of series parallel, just let us leave this and go to the next heading. So because there's no limit for the number of problems, try to understand. So what shall we do now? Look, this, we joined it by a wire like this without any resistance. That means we brought this point and that point to the same potential. Sorry. We brought this point of 4 and this point of 4 to the same potential. This is what you call as short circuiting. Think there was no this wire first. I just joined these two ends of the 4 with this wire. Since there's no resistance in this wire, I told you in the very beginning we defined that lines we draw in the circuits are having no resistance. And copper, for example, we practically use because it doesn't have so much resistance. And the 4, 6 and 4 which we showed are actually made of alloys, I told you. So there's a practical element in this. Children. So if these 2 points are the same potential, will current flow in 4? Tell me. Will current flow in 4? No. So therefore current flows only in 4 and 6. And here deliberately I have given 2 cells for a while. Though we will discuss that series and parallel in future, just remember these currents are, one current would go that way, one current would go this way. But finally there will be a current going in this direction. This cell will dominate because it's got 4 volts. That's the reason the equivalent EMF here you can simply write it as what? A 2 volt battery like this. And then 4 and 6. So what do I get now? 2 by 10. Any problem with this, children? No, still you are not comfortable with the potential idea, isn't it? Huh? That's the only idea we need to understand in this whole discussion. Currents anyway you are somewhat comfortable, but the potential idea seems to be bothering. Joining the ends of 4 with a resistance-less wire brings the 2 potentials at the 2 ends of 4 to the same value. So current does not flow. Potential difference is not there. Tell me. Sai Kiran, what do you say?
Followed.
N Sai Kiran?
Sure.
What happened?
సార్ ఒకసారి మళ్ళీ ఒకసారి చెప్పండి సార్ 4 నుండి కరెంట్ అనేది పాస్ అవుతుంది.
Piece I can will tell now. Come on.
They are at equipotentials, no sir. Potential difference is 0.
0. So if
Current
potential
won't flow.
is 0, why will the current flow?
ఓకే సార్. ఓకే సార్.
No. I mean, nothing else actually speaking. Actually, what happens, you see, when there was the circuit like this, okay, I'll put it as 2 here. Initially, circuit could have been like this. So there will be, this potential keeps on falling as we go like this. Current flows like this, I told you, right? So in the direction of current, potential will fall. So 2 will become something here, that will become something here, that will become 0 here. If I say this is 2 and 0. Do you follow that? Every time this is going to be the method, children. So 2 will be all over, this is 2. But when you go there, it becomes less, some x. When you go there, it becomes even less, some x1. Then finally it becomes 0. So that's how you need to go on looking at potential and potential differences. So initially there's a potential difference between the two ends. X was greater than x1. So x minus x1 was the potential difference previously. Now you join by a wire. No resistance wire, right? So what will happen is, for a while current will redistribute. Sorry, where did I put it? Here I should put, right? So if I join it by a wire, just remove this wire. So if I join like that, what's going to happen? Whatever current was going, now doesn't go the same way. Current flows in this wire in such a way that these 2 points are brought to the same potentials. So current in this will become 0. Current will flow in this wire, I told you. Whatever current was there will flow in either this way or that way. We can decide which is at higher potential later. So from that side or this side, current flows, and a current flow sets up in this and no current flow in that, because the potentials have to become same here. So that's how it happens. So this is one important idea. Now go for the 19th. Nothing serious. Who will tell me the answer for this?
1.2.
I don't know. Just tell me what is happening there.
Sir, they are in parallel, sir.
They are in parallel. That's all.
Parallel.
For that, if you want, you can think of bringing this whole 8 and place it this side. You can think of hold it here and put it here. This is no connection here. This bypass is no connection. So all this 8 is having same potential difference as 12. Do you follow this? If this is 24,
Yes,
this
sir.
time, if this is 0, 24 here, 0 here, which is same for 12 and also for 8. So, or if you want, you can just flip this 8 one this side. Do you follow? This 8 can be
Yes,
flipped
sir.
and put it this side. So this 8 and 12 are in parallel. What do you say? Are
Yes,
they-
sir.
So 12 into 8 by 12 plus 8. How much is this?
24 by 5.
96 by 24 are 20. So 24 by that you do. 24 by 20 by 96. This will enter. So
5 amperes.
5. Okay. Tell me. So can we leave the series and parallel circuit business and go for the next heading, children, on Monday?
Yes, sir.
Yes, sir.
There's one more problem left actually. Take this problem anyway. But what I want is from 10th class to now, whether you made it more fundamental in approaching these circuits, especially only series parallel, terminal PD, EMF. So there should be some extra thing you must have gained now. Otherwise, I told you, mind is very habit oriented. Once you get to a habit, whether it's good or bad, they'll remain. It's very difficult for the neural circuits to form again and then make new habits. That's why people say, no, what is that? Bad habits die very hard. I don't remember exactly. There's actually a physiological reasoning inside. Every time you learn something, you form neural networks. So you get into a comfort zone, like one above the other, one after the other, some kind of some silly thing you do. Every time the mind once again looks for that. So to kill those, to break those neural circuits and form a better neural circuits is always difficult. Do you know that? So that new thing now, that I look at a circuit in terms of potentials, equipotentials, potentials changing, same currents dividing, then you learn something.